Hello students, in this video we will learn about test of significance of difference between means of two samples. So whenever two samples are given with different mean and standard deviations, we can use the expression for standard normal variate as z equal to x1 bar minus x2 bar divided by square root of sigma 1 square divided by n1 plus sigma 2 square divided by n2, where x1 bar sigma 1 and x2 bar sigma 2 are mean and standard deviation of two large samples of size n1 and n2 respectively. Note, if samples are drawn from the same population, then sigma 1 is equal to sigma is equal to sigma 2. So if we substitute this here, the numerator sigma square will be common. We will take out of the square root, so that expression for z will be x1 bar minus x2 bar whole divided by sigma into square root of 1 by n1 plus 1 by n2. Second point, confidence limits for the difference of means of the population are x1 bar minus x2 bar plus or minus zc into square root of sigma 1 square divided by n1 plus sigma 2 square divided by n2, where zc are the critical values. Problems. First one, intelligent tests were given two groups of boys and girls. So for the two groups, mean, standard deviation and size is mentioned. Find out whether the two means differ significantly at 5% level of significance. Start the solution. First we assume that there is no significant difference between two means. Since here two samples are given with different means, we can use the formula z equal to x1 bar minus x2 bar divided by square root of sigma 1 square divided by n1 plus sigma 2 square divided by n2. Substituting all the values and simplifying, we get z is equal to 1.39, which is less than 1.96, which is the critical value of z at 5% level. So, at 5% level, the hypothesis is accepted, means there is no significant difference between means of two samples. Second problem. A sample of 100 bulbs produced by a company A showed a mean life of 1190 hours and standard deviation of 90 hours. Another sample of 75 bulbs produced by a company B showed a mean life of 1230 hours and standard deviation of 120 hours. Is there a difference between the mean lifetime of the bulbs produced by two companies at 1% level of significance and 5% level of significance? It is clear that two samples are given with different means. So we can apply the formula Z along with the two means. First we will list out the data. It is given that N1 is 100 for the sample with size 100, mean is 1190 and standard deviation is 90. And consider second sample, size is 75 and mean 1230 and sigma 2 is 120. We assume that the difference between the mean lifetime of the bulbs produced by two companies is not significant, or there is no difference between mean life of the bulbs produced by two companies. Since we have two different values for means, z is equal to x1 bar minus x2 bar divided by square root of sigma 1 square divided by n1 plus sigma 2 square divided by n2, and it is minus 2.42 on simplification. Taking mod z, it is 2.42. it is greater than 1.96 critical value of Z at 5% level, less than 2.58 critical value of Z at 1% level. So, the hypothesis is rejected at 5% level and accepted at 1% level of significance. The third problem is a random sample for 1000 workers in a company has mean wage of rupees 50 per day and standard deviation of rupees 15. Another sample of 1500 workers from another company has mean wage of rupees 45 per day and standard deviation of rupees 20. Thus, the mean rate of wages varies between the two companies. Find the 95% and 99% confidence limits for the difference of the mean wages of the population of the two companies. Start the solution. First, we make the assumption that mean rate of wages will not vary between two companies, or there is no significant difference between the mean wages of two companies. Now take two different samples. For the company 1, N1 is 1000, X1 bar is 50, sigma 1 is 15, and for the second company N2 is 1500, X2 bar is 45 and sigma 2 is 20. Since we are having two means for different samples, take the formula for Z as x1 bar minus x2 bar divided by square root of sigma 1 square divided by n1 plus sigma 2 square divided by n2. It is equal to 7.13. Note that this value of Z is greater than the critical values at both 5% level and 1% level. Hence, the hypothesis is rejected, means there is a significant difference between the mean wages of two companies. Now we have to establish 95% and 99% confidence limits. 95% confidence limits are given by x1 bar minus x2 bar plus or minus critical value is 1.96 into square root of sigma 1 square divided by n1 plus sigma 2 square divided by n2. Substituting all this, we get the values to be 3.6259 and 6.37415. So upper limit and lower limit for significant level. 99% confident intervals or confidence limits. Here critical value must be 2.58. So all other values same. Write 2.58 as critical value and simplify. 99% confidence limits will be 3.1912 and 6.8088. Next problem. In an elementary school examination, the mean grade of 32 boys was 72 with standard deviation of 8, while the mean grade of 36 girls was 75 with standard deviation of 6. Test whether the hypothesis that performance of girls is better than boys. So here hypothesis is given that performance of girls is better than boys. So for boys, take one set. X1 bar is 72, sigma 1 is 8 and n1 equal to 32. Take the sample of girls. For that set, x2 bar is 75, sigma 2 is 6 and n2 is 36. Since we have two means for two different samples, Z is equal to x1 bar minus x2 bar divided by square root of sigma 1 square divided by n1 plus sigma 2 square divided by n2. On substitution, we will get the value as minus 1.73. So taking the positive value, mod Z is equal to 1.73 and it is less than 1.96 critical value of Z at 5% level. So the hypothesis is accepted at 5% level of significance. That is, performance of girls is better than boys at 0.05 level of significance. The last problem is the mean of two large samples of 1000 and 2000 members are 168.75 centimeter and 170 centimeters respectively. Can the samples be regarded as drawn from the same population with the standard deviation 6.25 centimeter? In this problem, two samples are given with mean and size. So list them as x1 bar, x2 bar, n1 and n2. We will make the hypothesis that the samples are drawn from the same population with the standard deviation sigma equal to 6.25. We note that here only one standard deviation is given. So, in the formula for z, we will use the expression x1 bar minus x2 bar divided by sigma into square root of 1 by n1 plus 1 by n2. Substituting and simplifying, we will get z as 1.56. Note that this is less than 1.96 and 2.58, critical values of z at both 1% level and 5% level. So, the hypothesis is accepted. That is, the two samples are drawn from the same population with standard deviation sigma equal to 6.25. Thank you.